Good morning, everyone. I'm an aptitude trainer in the Department of Career Planning and Development, and today we will learn about the topic set theory. In the given topic, we will learn about what is a set, what is a subset of the set, power set, complement of a set, what is the cardinal number of a set, finite, infinite set, etc. And we will learn about how you can solve the questions in set theory by use of Venn diagram. So let's start with the topic. So what is a set? Set is a well-defined collection of objects known as elements. So what is a set? It is a well-defined collection of objects which is known as its elements. Well-defined means, what is the meaning of well-defined? Well-defined means it must be absolutely clear that which objects belong to the set or which does not belong to the set. So what is the set notation? We use curly braces. Set is always denoted by curly braces with elements separated by commas. If set is not defined under curly braces, we cannot say that that is a particular set. Set is all the elements, or set is always defined under curly braces. And the elements are always separated by commas in the set. For example, let's say A, 1 to 10. This is a set of first 10 counting numbers, or you can say set of natural numbers. And if this is a set B, in the given set B, red, blue, green, name of the colors are given. So this is a set of primary colors. We can say this is the set of primary colors. Next is N, 1, 2, 3 up to so on. Means this is the set of all the natural numbers. Set of all the natural numbers. And Z is the set of integers. What are integers? Starting from negative undefined value means infinity up to positive infinity. This is the set of all integers. So set which contains negative, 0 as well as positive values, that is known as set of integers. And the next one is null set, or you can say void set. Null set or void set. So a very important set. This is empty set. What is null set or void set? This is empty set or the null set which has no elements, And we denote the empty set by phi or only with curly braces and no element in the curly braces. That is known as null set, empty set, or you can say void set. So note that we can also write, for example, phi as x belongs to n and x is less than 0, because we know that natural numbers starting from 1, 2, 3 up to so on. But here we wrote x is less than 0. 0 means negative numbers. So in natural numbers, there is not any negative number. So what it means? It means this is a null set or void set. The next is subset. What is the subset of a set? So let's say if A and B are two sets and every element of set A is also an every element of set B, then A is called a subset of B. A is called the subset of B, and we can write what is the symbol of the subset. We can write A as subset of B, or we can say B is a superset of A. So the symbol this stands for subset, or you can say this is contained in A. A is contained in B. And remember this thing that every set is a subset of itself. Every set is a subset of itself. So we can say A is a subset of A and B is a subset of B. An empty set is a subset of every set. Remember this thing. Empty set is the subset of every set. So let's take an example. Let the elements in set A are given to us as 2, 4, 6, and elements in set B are given to us as 6, 4, 8, and 2. Here A is the subset of B. A is the subset of B because all the elements of set A are contained in set B. All the elements in set A, they are contained in set B. But B is not the subset of A. We cannot say B is the subset of A because there are few elements which are in B but not are in set A. Since all the elements of set B are not contained in set A, so that's why we can say B is not the subset of set A. Whenever A is a subset of B, we can say that B is the superset of A. B is the superset of A. Here we can write B is the superset of A, and this symbol is used to denote superset. This symbol is used to denote superset, and this symbol is used to denote for set. So in the given example, A is the subset of B, but B is the superset of A because all the elements of set B are not contained in set A. So that's why we call B as the superset of A and A as the subset of B. Move on to the next one, that is proper subset. Proper subset. If A and B are two sets, then A is called the proper subset of B if A is a proper subset of B. So you can see here we are using this symbol. We are not using this symbol. This symbol is used for subset. But when both the sets are not equal, we will use only this symbol. We will remove the equal sign. It means A is not equal to B, but it can be possible in subset. It may possible A is the subset of B or elements of A and B are equal. But if we are talking about the proper subset, so A cannot be equal to B. So symbol this is used to denote proper subset. For example, the number of elements in the given set A are 1, 2, 3, 4. Total number of elements are 4. And in set B, 1 to 5 elements are there. It means the number of elements in set B are 5. So we observe that all the elements of A are present in B, but the element 5 of B is not present in A, means this element. This element of set B is not present in set A. So we can say that A is a proper subset of B because A is not equal to B. Set A is not equal to B. So we can say that A is a proper subset of set B. Okay, move on the next one. Yes, power set. Power set. So what is a power set? The collection of all the subsets of set A is called the power set of A. Collection of all the subsets of set A is called the power set of set A. So it is denoted by P of A. So in P of A, every element is a set. Remember this thing that in power set, every element is a set. For example, if A equals to PQ, this set is given to us. A set is given to us and there are only two elements in set A, that are P and Q. Then all the subsets of A, all the subsets of the given set A, that are 5, because I have told you earlier that null set or Y set is the subset of every set. Only P, Q and PQ. These are the sets because these are defined under curly braces. So these are the sets. So number of elements of the power set of A, that is equal to 4 because 1, 2, 3, 4. There are 4 elements, or we can say 2 power 2. So this is the power set. Collection of all the subsets of set A is called the power set of set A. And here the total number of elements or sets, subsets of the set A, that comes out to be 4. It means in power set of A, how many elements are there? There are 4 elements. So in general, when you have to find out the power set of a given set, we can find out the power set by 2 raised to the power number of elements in the given set, where m is the number of elements in the given set. And in the given set, number of elements are 2. In the given set, number of elements are 2, P and Q. So we can say 2 power 2 means 4 elements will be there in the power set of the given set A. So this is known as the power set. Next one is the universal set. Universal set. So what is a universal set? A set which contains all the elements of other given sets is called a universal set. All the elements of other given sets, that is called the universal set. And the symbol to denote universal set, we will use this symbol. So let's take an example. If there are 3 sets, A, B, and C. In first set, means in set A, there are 3 elements, 1, 2, and 3. And in set B, again 3 elements are there, but these are different, 2, 3, and 4. And in the given set C, the number of elements are 3, 5, and 7. So what will be the universal set? So set which contains all the elements of the other sets, other given sets, that is called the universal sets. And there are 3 sets are given to us, A, B, C. So universal set of these sets 1, 2, 3, 4, 5, and 7 means we need to write all the elements of the 3 given sets in one set. That is known as the universal set. So this is known as the universal set of the given sets A, B, and C. This is the universal set. And A is the subset of universal set, B is the subset of universal set, and C is the subset of universal set. Or you can say this universal set is the superset of A, B, and set C. Right, so this is universal set. The next one is complement of a set. Complement of a set. So in complement of a set, if E be the universal set and A is a subset of E, let's say E be the universal set and A is a subset of the universal set E, then the complement of A is the set of all the elements of E which are not in the element of A. So what is the complement of the set A? So we need to write all the elements of set E which are not the elements of set A. That will be the elements of the complement of the set A. Symbolically, we denote the complement of set with respect to E as this. Or we can say A power C. We can also denote the complement of a set as A power C or A dash as the complement of a set. So for example, let's say in the universal set E, there are elements 1, 2, 3, 4, 5, 6, and 7. And there is a set A. And in set A, the number of elements are 1, 3, and 7. Then what will be the complement? What will be the complement of set A? So complement of the set A, we need to write all the elements of the universal set E which are not the elements of A as 1, 3, 7. 1, 3, 7, these are the elements of set A also. So we need to skip these elements and we need to write the elements which are not in set A. So we are left with 2, 4, 5, and 6. So there are 4 elements, 2, 4, 5, 6, which are not in set A. So this will be the complement of the given set A. This is the complement of the given set A. The next one is, what is a finite set? Finite set, by the name, this is clear that the finite set are the sets having a finite or countable number of elements. Finite or countable number of elements, that is known as finite set. Finite set is also known as countable sets as they can be counted. This can also known as countable sets as they can be counted. So the numbers which we can count, they are known as countable numbers. And the set in which the given number of elements we can count, that is known as finite or countable set. For example, if a set P is given to us with the elements 0, 3, 6, 9 up to 99. So we can count these elements. So this is known as a finite set. In Q, set Q, if A is the integer which lies between 1 and 10. Integer which lies between 1 and 10 means from 2 to 9. So we can count that numbers. So that is a finite set. And we can say a set of all English alphabets, because there are 26 English alphabets. So we can count. So that is known as finite set. So the set in which we can count the number of elements, that is known as finite set, or you can say the countable set. Now, what is infinite set? If a set is not finite, not countable, uncountable, that is called infinite set. If a set is not finite, then it is called infinite set, because the number of elements of that set are not countable. Number of elements of that set are not countable. So thus infinite sets are also known as uncountable sets. Infinite sets are also known as uncountable sets. For example, a set of whole numbers from 0, 1, 2, 3 up to so on. As we know, whole numbers are uncountable. So that comes under infinite set. Set of all the points on a line. As on a line, we can take as many points as we want. So that is uncountable. And the set of all integers means from negative infinity up to positive infinity, undefined. So we cannot count these numbers, integers. So we can say this comes under infinite set, uncountable, infinite set. Yes, next is the cardinal number. What do you mean by cardinal number or cardinality of a set? So if A represents the number of elements of set A, then the cardinality of a finite set N of A is A. Means simply the number of elements in the given set, that is known as its cardinal number. For example, cardinality set of all English alphabets is 26, because there are 26 English alphabets are there. So the cardinal number is 26. Similarly, for a set containing the months in a year, we'll have a cardinality of 12, because in a year there are 12 months. So number of elements for that set, there are 12 elements. So we can count these 12 elements. So the number of elements means its cardinal number. Cardinal number means the number of elements without repetition. That is known as the cardinal number of the given set. Next is equal sets. What are equal sets? So two sets A and B be equal if each element of set A is also the element of set B. Each element of set A is also the element of set B, that is known as equal sets. Also, if two sets are subset of each other, they are said to be equal. This is represented by A equal to B. A is a subset of B, or B is a proper subset of A. And we can say A equals to B. Means the cardinal number as well as the elements. If two sets have the same number of elements as well as the same elements, then they are known as equal sets. Here you can see there are two sets P and Q. In set P, the elements are 1, 3, 9, 5 and -7. Means in total 5 elements are there. And in set Q, 5, -7, 3, 1 and 9. Again 5 elements are there. And all the elements are same. Elements of set P is also the element of set Q. it means P equals to Q. These are known as equal sets. If the cardinality of the number of the set as well as the two sets having the same elements, that is known as equal sets. That are known as equal sets. The next one is equivalent set. This is little bit different from equal set. So two sets A and B are said to be equivalent if they have the same cardinality. If they have the same cardinality, it doesn't matter that they both have the same elements, but number of elements in both the sets, it should be same. For example, if in the first set P, 1, minus 7, 22, 5. These elements are there, total number of elements are 4. And in set Q, 1, 2, 3, 4. Again, 4 elements are there, but the elements are different. Elements are different. Then we can say P is equivalent to Q because their cardinal number is same. If the two sets are there and if their only cardinal number is same, that are known as equivalent sets. But if the cardinal number as well as the number of elements as well as the elements, they have the same elements, that is known as equal sets. Every equivalent set is equal. You can say every equivalent set, you can say equal. But equal set may or may not be equivalent. All right, so this is about equivalent and equal sets. Next is the difference of sets. Difference of sets. The difference of set A and B is written as A minus B. This is the set of elements belonging to set A and not to set B. So what do you mean by A minus B? If we separate all the common elements of set B from set A, then we can say that A minus B means the set of elements belonging to set A and not to set B. For example, there are two sets A and B. In set A, there are 5 elements and in set B, there are 3 elements. So what is the difference of set A and B? Means A minus B. If we remove all the common elements of set B and set A, then we are left with the elements which belong to only set A, but not to set B. That is known as difference of two sets, means A minus B. So note that A minus B, it cannot be equal to B minus A. Difference of two sets A minus B, it cannot be equal to B minus A. Remember this thing then. Next, we will learn about the union of sets. What is the union of sets? So union of two given set is the smallest set which contain all the elements of both the sets. All the elements of both the sets. Let's say two sets are given to us, and if we combine both the elements of the two sets by removing the common elements, that is known as the union. So to find the union of two given sets A and B, this is a set which consists of all the elements of A and all the elements of B, which are as no element is being repeated. Symbol for union, we will use this U. For example, there are two sets A and B. In set A, 2, 4, 5 and 6, these elements are there. And in set B, 4, 6, 7 and 8 elements are there. So what is A union B? So we will combine both the elements. Elements of both the sets, that is known as its union, by removing common elements. 2, 4, 5, 6, 7, 8. So this is the union of two sets. This is the union of two sets. And the next one is intersection of two sets. What is the intersection? So intersection of two given sets is the largest set which contains all the elements that are common to both the sets. That are common, only the common elements we will use intersection. So to find the intersection of two given sets A and B, this is a set which consists of all the elements which are common to both A and B. It consists the elements which are common to both A and B. And we will use this symbol to denote intersection. For example, there are two sets, set A and set B. In set A, the number of elements are 5, that are 2, 3, 4, 5 and 6. And in set B, 4 elements are there, 3, 5, 7 and 9. Now we have to find out A intersection B. Means we need to choose the elements which are common to both the sets A and B. So as we can see, 3 and 3, that is common in both the sets, and 5 is common to both the sets. So there are two elements, only 3 and 5, which are common to both the set A and B. So this is known as its intersection. Intersection of set A and B is 3 and 5, only the common elements. Now, move on the Venn diagram. So Venn diagram, also known as Euler Venn diagram, this is a simple representation of sets by diagram. We can solve the question by using the Venn diagram concept. So these are two basic formulas that we will use. So that is number of elements of A union B, that is equal to number of elements in set A plus number of elements in set B minus their common elements, minus the common elements of set A and B, means A intersection B. But if there are 3 sets A, B, C are given to us, then the number of elements in the union of set A, B and C, that is equal to n of A plus number of elements in set B plus number of elements in set C minus number of elements in both the sets A and B minus the common elements of B and C and minus the common elements of C and A plus the common elements of both the three, all the 3 given sets. Common elements to all the 3 given sets. So let's take one example, then this will be clear to you. Yes. If in a college 200 students are randomly, if in a college 200 students, they are selected, so in a college 200 students are randomly selected, 140 like tea, 120 like coffee and 80 like both tea and coffee. So how many students like both tea or are like only tea? How many students like only coffee? How many students like neither tea nor coffee? And how many students like only one of tea or coffee? And how many students like at least one of the beverages? In total, 200 students are there. They are randomly selected. Out of 200 students, 140 like tea and 120 like coffee and 80 like both tea and coffee. 80 like both tea and coffee. So first of all, we will make the Venn diagram. So these, yes, these are the students. First circle shows the number of students who like tea. And the second, who like coffee. And this is the common part, like both tea and coffee, which like both tea and coffee. So this outer rectangular part showing that the number of students who do not like tea or coffee. 200 students are there. 200 students are there. And out of 200 students, 140 like tea. 140 like tea. So first we need to find how many students like only tea. Only part. Only tea means if we subtract this both part, which like both tea and coffee, we will having only tea part. So as 140 students like tea, out of 140, 80 students like both tea and coffee. This contains 80 students. So we are left with 60 students. It means 60 students are there which like only tea. 60 students are there which like only tea. The second part is how many students like only coffee? How many students like only coffee? It means 120 students are there who like coffee. So if we separate this common part, the students like both tea and coffee, we are left with the number of students who like only coffee. And there are 40 students who like only coffee. Now, how many students like neither tea nor coffee? How many students are there which like neither tea nor coffee? As 60 students are there which like tea, only tea, 80 like both, and 40 like only coffee. It means in total how many students are there which like only tea, only coffee, or both? 180. And how many students are there? 200. So out of 200, if 180 like both or either of the drink, so we are left with only 20. It means 20 students are there which like neither tea nor coffee. 20 students are there which like neither tea nor coffee. And the next part is how many students like only one of tea or coffee. So how many students are there which like one of only tea or coffee? As 60 students like only tea and 40 students like only coffee. It means in total 100 students are there which like only one of tea or coffee, either tea or coffee. The next part is how many students like at least one of the beverages? At least one of the beverages. So at least one means either only tea or both or only coffee. It means 180. 180 students are there which like at least one of the beverages. What do you mean by at least? Minimum one of the drink, maximum they like both the drinks. So minimum one of the drink means as tea, only tea. So 60 students are there which like only tea. 40 are there which like only coffee, and 80 students are there which like both. So how many students like at least one of the beverages? There are 180 students. So 180 students are there which like at least one of the beverages. Now move on the next one. Yes. So in a survey of 500, we find that 500 students of a college, it was found that 49% like watching football. In total, there are 500 students. Out of 500 students, 49% like watching football. 53% like watching hockey. 62% like watching basketball. Also 27% like watching football and hockey both. 27% are there which like both hockey and football. 29% like watching basketball and hockey both. And 28% like watching football and basketball both. There are 5% like watching none of these games. 5% students are there which like watching none of these games. So first we have to find how many students are there like watching all the three games. How many students are there which like watching all the three games. So first we have to find out the number of students. So for example, as 5% like watching none of these games. 5% watching none of these games, it means how many percent of students watching at least one of the game? There are 95%. As percentage sign is there, so we are assuming the total students as 100. So out of 100, if 5% like watching none of these games, it means 95% the students are there watching at least one of the game. So A union B union C, as there is football, hockey, and basketball is there. So it means the union of F union H union B, that is given to us as 95%. So this is equal to number of elements in A. So number of elements in A means 49%, then 53%, then 62%, and minus A intersection B means 27% like watching football and hockey, and 29% watching basketball and hockey, and 28% are like watching football and basketball. And now the intersection of these three. Yes, intersection of these three. So now we have to find out the intersection. So you need to calculate all these. So when we calculate it, we will get 15%. It means 15% students are there which like all the three games. Like all the three games. So how many students like watching all the three games? 15%. We can also make the Venn diagram as hockey, football, and basketball. Three games are there. So we have to make 3 circles, right? 500 students are there. 49% like watching football. 49% like watching football. So this is the circle only football. This part is only football. This part is hockey. And this is basketball. And as we know, 5% are the students liked watching none of these games. 5% are the students watching none of these games. So we are writing 5% outside. As 49% watching football. 49% watching football. And the intersection of this 27 like watching football and hockey both. 27% like watching football and hockey, and 29% like watching basketball. So as 27% like watching football and hockey, this whole part, this is the common part of hockey and football. But this is the common part of all the three games, and that we have find out 15. I will make the diagram on the next slide. Yes, that will be more clear to you. So let's say yes, hockey, football, and basketball, and 5% are the students which like none of the given. As 15% are the students which like all the three games, that is A intersection B intersection C. And as we have 27% are the students which like, 27% are the students which like hockey and football, means hockey intersection football, that is 27%, and 29% like watching basketball and hockey. 29%. And the last one is 28% like basketball and hockey. 29% liked basketball and hockey, and 28% watching football and basketball. Football and basketball, that is 28%. And initially, that is given to us, the number of students who liked watching football, that are 49%, and basketball 62%, and hockey there are 53%. 53% are the students which like hockey. Now we have to find out this portion. This portion. As we know, hockey and football, how many percent students like hockey and football both? 27. So out of 27, 15 is there. It means this will be 12. This will be 12. Now the common portion of hockey and basketball. Hockey and basketball, the common portion is this. As 15 like all the three games, and hockey and basketball 29. 29 students are there which like basketball and hockey. It means this will be 14. Now football and basketball. The students which like football and basketball, 28%. 15 is there, remaining 13. 15 is there, remaining 13. Now we have to find only hockey. How many number of students are there which like only hockey? So hockey, there are 53% students are there which like hockey. 53% students are there which like hockey. And we have to find out the students which like only hockey, not any other game other than hockey. So only hockey. So if we subtract these three, means 12, 15 and 40, 41. Out of this 53, because 53 students are there, 53% students are there which like hockey. So if we subtract the common portion of hockey with football, basketball and all the three games, so we are left with the number of students which like only hockey. Which like only hockey. It means 12% students are there which like only hockey. Same with football. Total number of students which like football, 49%. This is about hockey, 12. Now football, 49. Out of 49%, we have to subtract this 12, 15 and 13. So minus 12, 15 and 13. We are left with only 9. It means 9 students, 9% students are there which like only football. This is the only portion. Now we are left with basketball. As total 62% students are there which like basketball. So if we subtract the common portion, that is 14, 15 and 13. It means minus 42. So we are left with 20. So 20% students are there which like only, yes, which like only basketball, only this portion. So only basketball 20 students, only football 9 students and only hockey 12 students are there. Only hockey 12 students are there. Now we have to find, second part is we have to find the number of students who like watching all the three games. First, we have find out 15% of the students like all the three games, and total number of students are given to us as 500. So what is 15% of 500? That comes out to be 75. It means how many students are there which like all the three games? 75 students are there which like all the three games. And this, in the second part, we have to find the number of students who like watching only one of the three given games. only one of the 3 given games. So we have to find the number of students, one of the 3 given games. One of the 3 given games. So only football, that is 9%, only hockey 12%, only basketball 20%. So we have to find out this percent value of 500. And when you solve, you will get 205. It means 205 students are there who like watching only one of the 3 given games. And the last part that we have to find the number of students who like watching at least 2 of the given games. At least 2 means at least 2 games or maximum 3 games. At least 2 means 2 games or maximum 3 games. So, yes, 12, 13, 14, 15%. This 12 common portion, 12, 13, 14, 15. 15 means all the 3 games, and that comes out to be 54%. So we have to find 54% of 500, and that comes out to be 270. It means 270 students are there which like at least 2 of the game, means minimum 2 games but maximum all the 3 games. So there are 270 students are there. So this is all about today's session. Thank you so much.